Alright, so we're going to solve absolute value inequalities. It's very, very similar to the equations. So first thing you need to do is be sure the absolute value is isolated. So I don't see anything in front of it, and I don't see anything after it. So it's already been isolated. It has a positive over here, so I'm going to have two equations, or inequalities. So I'm going to separate it. The first time I just write x plus 4 is greater than or equal to 6, just without the absolute value bars. And then the second time, I'm going to flip the inequality symbol and make it a negative. So x plus 4 is less than or equal to negative 6. That's the only difference with setting it up, is that you have to flip the inequality symbol on the one that's negative. Alright, I'm going to solve the left one first. All you need to do is minus the 4 to the other side. I get x is greater than or equal to, and 6 minus 4 is 2. Take the exact same steps to the other inequality. Subtract 4. X is less than or equal to, and they're both negatives, so that would make it negative 10. So we're almost done, but now I need to decide if this is going to be a compound inequality or an OR inequality. So to help me figure it out, I use a number line. I'll put 0 here. This is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's negative 10. So I'll do this first one in purple, the 2. It says x is greater than 2. Greater is this way. Numbers like 3, 4, 5, 6, those are greater than 2. And then I'll use green for this one. Negative 10. X is less than negative 10. That would be numbers that are to the left. Like negative 11, negative 12, negative 13. Those are less than negative 10. Here's a trick to help you figure out which way to shade. This kind of looks like an arrow pointing to the right. So then you shade to the right. That kind of looks like an arrow that's pointing to the left. So you shade to the left. So the numbers over here in the green area, those are numbers that are less than or equal to 10. And the numbers over here in the purple area, those are numbers that are greater than or equal to 2. And these are different areas. Like you can't be at the same place at once. You can't be green and purple. It's one or the other. Either you're over here or you're over here. But you can't be in both places at the same time. So that makes this one an OR inequality. You just put the word OR in between them, and that is your whole answer. Okay. Now, if the shading was on top of each other, then it would be a compound inequality, and we could write it differently. All right, let's try the next one. So again, first thing is always to make sure the absolute value is by itself. It is. I don't see anything in front of it. I don't see anything after it. And on the right hand side, I see a positive number. So I'm going to do it the same way I did the first one. Just split it. The first time I write it as 2x minus 7 is less than 4. And the second time is 2x minus 7 is greater than negative 4. So I flipped the inequality symbol and made the right side negative. Alright, I need to solve it, so I would add 7 to get rid of that. 4 plus 7 is 11. And then I would have to divide to get rid of the 2. So x is less than, and you can leave it as a fraction, but since I'm using a number line to decide what kind of inequality I have, I'm going to turn it into a decimal. So x is less than, and if I divided that, that would be 5.5. take those same exact steps on the other inequality, so add 7, which is 3. Divide by 2. X is greater than 3 over 2, or as a decimal, that's a 1.5. Alright, so I'm done solving. I just need to decide how to write my answer. So I'm going to use a number line again. Here's 0, 1, 2, 3, 4, 5, 6. I'll put the first one in red. 5.5 would be in between 5 and 6. X is less than 1.5, so that way, or 5.5, sorry. Again, remember it looks like an arrow pointing to the left, so shade to the left. I'll use green for this one. 1.5 is right here. X is greater than that, so it's shading that way. So this time you can see there's a double shaded area. The green and the red are shaded in the same place, so any of these numbers that are both green and red, those are possible answers, right? So since it's shaded together, this is a compound inequality because there's numbers that can be both. Like for example, 3 is less than 5.5 and it's greater than 1.5. Right, so if it can be both things, we call it a compound inequality. And I'm going to write it together. So when we write it together, I just go smallest to largest because that's the easiest thing to do. We're already kind of used to seeing it like that because of domain and range. So my smallest was 1.5 is less than x is less than 5.5. So what you end up having to do is switch this sign because I switched where the x and the 1.5 are. Like I put 1.5 first instead of x first. So if you just think about, I'm going to go old school with the alligator. The alligator eats the bigger number. So you see the alligator's eating the x and not eating the 1.5. The same thing for this first half of it. The alligator's eating the x and not eating the 1.5 because that's the smallest. And then for this one, it still looks the same. X is less than 5.5. X is less than 5.5. Okay. So one of them you're always going to end up having to switch when you're doing a compound inequality because I'm putting x in the middle. So if x is always on the left-hand side, you end up having to switch one of them. So the easiest way to think about it is just go smallest to largest, and then your inequality symbols should always face the same way because the alligator always eats the bigger number. Vivi, you're asking if the answers will be fractions. They absolutely can be fractions. On y'all's assignment on Monday, y'all don't have an assignment today, but on Monday, for Delta Math, I don't remember if there's fractions in your answers for that one. But you will be able, if this is a fraction, you can leave it as a fraction or you can write it as a decimal, whichever way. I always turn them into decimals for inequalities because it's hard for me to think about like where is 11 over 2 on a number line. I'm not really sure, so I need to use decimals, but that's personal preference. You don't have to do that. All right, our third problem. Always start by being sure the absolute value is isolated. I don't see anything in front. I don't see anything after. That's good. On the right hand side, I see a negative. So I already know I can put my pencil down. I'm not going to solve this problem. My answer is either going to be no solution or all real numbers. And it depends. So remember that absolute value makes everything positive. So I don't know what number this is because I don't know what x is. But I know whatever it is going to be positive because absolute value is positive, right? So some positive number is less than negative 10. Can y'all think of any positive number that's less than negative 10? Your silence is correct. There's no number, no positive number is less than negative 10. That doesn't make any sense. Positive numbers aren't less than negative numbers, right? Negative numbers are less than positive numbers. So this doesn't make any sense. You can't have positive less than negative. So that means this is no, let me use a different color here, no solution. I don't have any others that have the all real numbers, so I'm going to show you right here what that would be like. So if absolute value of 3x plus 5 is greater than negative 10, then, so if we think about this one, again, I don't know what this is, but I know it's positive. So positive is greater than negative 10. Are positive numbers greater than negative 10? Yes, no, yes, yeah, absolutely. All positive numbers are greater than negative 10, right? So since all the numbers, all positive numbers are greater than negative 10, then it's all real numbers. So if your absolute value is already isolated and you have it not equal to, but you have a negative on the right hand side, then either your answer is no solution or it's all real numbers. And it just depends on which way the symbol is facing, right? So it's never going to be less than a negative number, but it's always greater than a negative number. Our problem. I'm going to start this one with y'all and then let y'all try it. But I'm going to start it with y'all because we finally have something outside the absolute value sign, the +2. You can't have that. So we're going to move it over first by minusing 2 to the other side. The absolute value of 2x plus 6 is greater than 1. Now it's ready to be split because it has a positive over here, so you can split it to the two inequalities. So I'm going to give y'all a few minutes to try that, and then we will go over it. Okay, so I'm going to split it. Negative 2x plus 6 is greater than 1. Negative 2x plus 6 is less than negative 1. I would subtract 6. Negative 2x is greater than, that's negative 5. And then we divide by negative 2, and I'm dividing by a negative. That means I have to flip my inequality symbol around. And negative divided by negative is positive. If you want to write it as a fraction, you can, or as a decimal is 2.5. Same steps over here, except that would be negative 7. And divide it. Again, I'm dividing by negative, so I flip the symbol. Negative divided by negative is positive, so either 7 over 2 or 3.5. Okay, my number line, 1, 2, 3, 4. I'll put the 2.5 in green, it's like right here. X is less than, so it's that way. This one's in purple. X is greater than, so it's that way. So these are shading opposite of each other because of since I had to flip the inequality symbols, they're opposite of each other, so I just put the word or in between it, and that's it. So I got a lot of almost correct answers. I think the problem was some of y'all didn't flip the inequality symbol when dividing by a negative, so that changed like how your final answer would have been. Because if we didn't flip them, then it would have been a compound inequality. But we had to flip them, so it's an or inequality.